we are going to talk about one of the important topic of phase equilibrium, that is one component system, that is water system. So water is known for so much long time, and we are going to study about water system. In water can present in three different phases, that is namely solid, liquid and vapor. So with these phases it can be equilibrium in three different ways. So here I have mentioned some of the important equilibrium, that is liquid is equilibrium with vapor, solid that is equilibrium with vapor, and solid that is equilibrium with liquid. So today in this video we are going to learn about the phase diagram of water. So this is the phase diagram of water. So this plot is basically pressure versus temperature. This plot is pressure versus temperature. So here your pressure is in mmHg and temperature is in degree Celsius. So this graph is not to the scale, but here as we can see, graph contain three major lines, that is OA, OC, OB. OA, this curve we say vapor pressure curve. OC, this curve we call it a fusion curve. OB, this curve we call it sublimation curve. So we are going to discuss about these three different curves. So the graph indicates, here we are going to observe if you keep the pressure fixed and if we are varying the temperature, what effects are going to in physical form that we are going to observe here. Suppose take one system. This is the one container and this is the piston. This is this is not given in the book. I am just giving the example just to make sure that students should get better understanding, like physically, visually it can visualize the physical process of water system. So here first we have taken inside solid ice. Solid ice. Suppose ice is there, 1 kg or 1 liter of 1 liter water of that ice contained is there in container, right? Now we are going to observe what effects are going to change. Now initially we have taken this condition. This is 1 atmosphere. Our surrounding atmosphere is 1 atmosphere, and that is 760 mmHg, that is in respect to of mercury. Now we are keeping pressure here fixed and we are changing the temperature. Suppose starting we have taken minus 20 degrees Celsius. So at this temperature the water forms in liquid state, solid state, that is in ice. Now we are going to change the ice from minus 20 to, slowly we are increasing the temperature. Okay. So at this temperature minus 20 your ice will be there. So this whole phase is represented as a ice. This from this COB, this whole before this water present in the form of ice. So from minus 20 we are slowly increasing the temperature. Now what is happening? So whatever here we are providing heat using the burner to the system, right? This is the burner and burner is heating to the system container, and that heat is absorbing the system. This heat is absorbing the system. So we are checking minus 20 slowly increasing. Now your temperature is minus 10. Still it is in ice form. Now the system come to the burner temperature. Suppose we have get one thermometer here for better understanding. Now your temperature is 0 degrees Celsius. Suppose your temperature is 0 degrees Celsius at a given point. Now your system has 0 degree Celsius. Now water heat you are providing using the burner to the container, that all heat that going to accumulate into the system. Now after that, up to 0 degree Celsius, whatever heat is providing, system is consuming, storing. Now after this, at 0 degree Celsius, your phase are going to change. So water you are providing the heat using the burner to the container, that heat is utilizing to convert the ice to water or liquid. Now slowly your system will start melting, right? So slowly it will start melting. So at this point you have some, instead of ice you will be having some water. So half of the, suppose I am taking, your half of the system is water is there. Suppose your half of the system is, so here water is there, that is in liquid form. That is in liquid form. Now what happening? Your system, whatever the heat is providing using the burner, that is utilizing to convert the solid to liquid state of system. Now after certain time, that all heat is when all ice is turned to the liquid state, at that point your temperature will start rising further that. So up to that it will absorb the heat. So for that situation, the phase change, that we call it isothermal system. We call it isothermal system. So we are going to learn about thermodynamics also as well. So your temperature is 0 degree Celsius. Only water your heat is providing, that is utilizing for just to change the phase. So while solid is there, ice is there, that is completely converting to the liquid. So now at the point your whatever the ice was there, it is completely converted to the liquid form now, right? So this is the second case. So now your ice is become completely liquid, 100% liquid. Right? So now your temperature will start rising. So if we see 0 will not be there. So you came up to this point. So you are increasing. So up to this point, for this point we call it freezing point, or we can say it a melting point, depending upon the situation. Fine. For this point we call it freezing point of the water. So before this it was ice. So at this point, that is ice is equilibrium with the liquid. Ice is equilibrium with the liquid. Now temperature is slowly increasing from 0 degree Celsius to up to 100 degree Celsius. Up to 100 degree Celsius. Now again, whatever we are providing it using the burner to the system, that all heat that it is going to absorb into the system, or it will go stored to the system. So at that point your liquid will be continuously absorbing the heat from the burner. Okay. So up to 100 degrees Celsius, your temperature will rise continuously. Again same situation comes. Now at 100 degrees Celsius, we know the boiling point of water. So boiling point of water is 100. So this line represents the two different phases are available in the system. So at 100 degrees Celsius, your water will start boiling. So it will represent as a vapor, right? So I am taking another example. Now you have 50% liquid and 50% vapor. Suppose you have liquid as well as now here vapor is also there. I am just showing you like diagrammatically. So this is the vapor. So and this, for this condition also we can say that is in equilibrium, and this system we call it isothermal. So after at 100 degrees Celsius, whatever you are providing the heat, that is you utilizing for to get the work done. That is, work means here phase change. So from liquid to vapor. So the continuously one by one molecule is getting converted to the vapor phase. So at one point your 100% liquid will get to the converted to the vapor phase. So we for that then we call it, so 100% of phase change will occur. So here we can say completely now your everything will be in vapor state, right? Everything will be in vapor state at 100 degrees Celsius. You can say 100 degrees Celsius. So up to that it will act as a isothermal. So above 100 degrees Celsius it will be in vapor phase. So at this point, Z point, we call it it's a boiling point of water. So this is freezing point and this is the boiling point, and after that this is in vapor form. This is in vapor form of water, right? So we can say it is in vapor form of water. Now we are going to see the another condition, that is, if you are lowering the pressure. If you are lowering the pressure, what going to happen to the phase of the water system? Now we are reducing the pressure, right? Reducing the pressure means you are increasing the volume. So suppose you are increasing the volume, so your piston is going up and up and up. So at that point your pressure will inside container pressure will be get reduced. So 4.58 mmHg. So compared to 760 mg, this value is very low, right? This value is very low. So at this point, what is going to happen that we are going to observe? So according to this phase diagram, the O system represent. So at this point, all three phases are there in equilibrium. So here here in this phase your liquid is there. From here to here all solid is there, and from here to here all vapor is there. So at this point O, it represents your all three phases are in equilibrium. So if you are reducing up to that point and you are increasing the temperature from 0 degrees Celsius to 0.0075, so at that point you have a triple point. So this we call it triple point. So at that triple point you are at triple point your solid, that is in equilibrium with liquid, and that is in equilibrium with vapor. So your all three phases are in equilibrium with the system. So at this point ice will be also there, your water also will be there, and vapor also will be there, right? So up to that, and your temperature is slightly greater than the 0 degrees Celsius, right? That is 0.0075 degrees Celsius.